I visited a couple of recycling facilities a few years ago, and I mean, everything you say really resonates. I would say, in addition, the thing that really stuck with me in terms of discomfort of being there was the noise. Like, there was so much noise. I mean, because so many of these machines make so much noise that are shaking, and that's they're shaking on purpose. Normally, when a machine is shaking, vibrating, you want to fix it, it's not supposed to, but they're violently shaking because that's how some things get separated, and so it's just part of the whole thing. So much noise, and also what I saw on the belt is like very sharp things on the belt. So I mean, obviously workers wear protective gloves and so forth, but I mean, it just but then I would say, when I looked at it, my reaction maybe wasn't yours. You said, "Oh, maybe it should be easy," but my reaction was, this is going to be very hard, because even though for humans it might be easy if you stay focused, or the belt goes pretty fast, so you got to keep up. As you say, everything's smashed, and to me that seems really hard to have an AI/vision system that can handle all this variation, because you never see the same situation twice. It's so unstructured. I mean, at the time, deep learning wasn't as good yet back in 2014 as it is today. I mean, was it already feasible at the time, or was it the whole process to kind of build up the system to become good enough?
Yeah, no, I definitely am being a little bit glib about it. There's multiple layers of difficulty in there. Just like you're saying, the grasping problem is really difficult. The stuff is smashed up. It's also all piled together, and so it's really hard to kind of get a good hold of things. And then, the inconsistency. The inconsistency is really hard in a couple of ways. It's not just the fact that it's smashed and folded and dirty, like that. That really is the core of it. But there's so many different types of packaging out there, and you have to have a good system. You have to deal with a huge fraction of it right up front, right? So you're dealing with all these different types of plastics. One of the materials we started with was cartons, so milk cartons and juice cartons. And that was really hard to start with, because they're boxy and they have a lot of similar graphics with things like cereal boxes and other boxes. And so, the vision system was using like, symbols and graphics and things like this, like logos, but those were shared across other items. And so there was a lot of confusion of the system between things. I think, and you're right. The deep learning was pretty nascent. So some of the first systems we made actually used support vector machines, which is sort of the technology that was before that. But I think we had this faith from seeing some of the early results for like like identifying cats in YouTube videos, like that paper that like seemed like a similar problem. And so with enough data, we would be okay. Mm-hmm. So what we found was, there's a couple things that work to your advantage. Because it's so difficult, the industry actually has pretty loose standards on material quality. And so you don't, like, if you look at a manufacturing environment, you really need to be like 99.9%, accurate or higher, actually much higher in most cases. In the recycling industry, a purity standard of kind of 90 or 95% is considered like, that's pretty good. And so that ends up giving you a lot of slop that you can use when making an initial system. That's kind of what we did, is we just kind of focused on a couple pieces of packaging and then just kind of kept adding to the data set. But like the initial versions of our system did not work very well. And actually we broke a lot of robots. And in terms of like some of the other things you brought up, like there are real hazards. People put hypodermic needles, knives, propane canisters in the recycling, and all of these things can hurt people. We had like bowling balls hitting the robots and stuff like that. And the biggest hazard for us, or for the robot, the thing that the robot buster was, it was stuff the robot actually should have like had to deal with. It would be milk jugs that were fully inflated with a cap on it. And if the robot hit it hard going too fast, that could blow up the robot. Also just boxes, like some boxes are so strong. You really don't think about it, but you could stand on one. And so for these industrial robots, if they plow into it, you can break them really fast.